All right, so in this example, we want to determine if this series is going to converge or diverge. Since we just learned the ratio test, you might guess that we're going to try the ratio test here. And so the ratio test, I'm just going to write down what we're trying to do here. First of all, in the ratio test, the terms have to be non-negative. Does that work here? Are the terms non-negative? Yeah, so we don't even have to worry about the absolute series here. It's already an absolute series. So the terms have to be non-negative, and then what we want to look at is the limit as n approaches infinity of the ratio of the n plus first term to the nth term. And if this ratio is approaching some value, then we might be able to make a conclusion. So my first task is to write the n plus first term and the nth term. And I'm just going to do this off to the side. You don't have to do this work off to the side. You can just go ahead and rewrite this. We'll come back and do that in a second. But just to be clear about what we're doing here, I'm gonna do a little bit of this off to the side. What is the n plus first term going to be in this series right here? What do I get on top? 5 to the n plus 1 over n plus 1 factorial. And the nth term is going to be what? That's easy. That's just this right here. 5 to the n over n factorial. Okay? So this ratio here, or this limit that we want to evaluate, is going to be this. Limit as n approaches infinity, and don't forget that limit. That's important. The n plus first term goes on top, so we're going to have 5 to the n plus 1 over n plus 1 factorial. And that's all over 5 to the n over n factorial. Might look a little bit crazy right now, but it's not bad, I promise. What would be an easy way of simplifying this complex fraction here? Cool? So if we rewrite it by multiplying by the reciprocal, we're going to have the limit as n approaches infinity of 5 to the n plus 1 over n plus 1 factorial times n factorial over 5 to the n. And when we're doing the ratio test, this is usually what's going to happen. We're going to have stuff cancel out. In fact, if stuff doesn't cancel out, then that's going to be one of those cases that is probably not going to work for you. So there's a couple of things here that are going to simplify. Cole, you said the factorials are going to cancel? Okay. How are they going to cancel?
Well, it would be the n factorial.
So since n plus 1 factorial is the same thing as n plus 1 times n factorial, then these are going to cancel, and all that's left down here is n plus 1. What else is going to cancel? How many 5s are being multiplied by each other here? N. How many 5s are being multiplied by each other here? N plus 1. So we have n plus 1 5s being multiplied here, n 5s being multiplied here. So they're going to cancel each other out, and what's left on top? 5. Yeah, 5 to the first, or just 5. So what we get here is the limit as n approaches infinity of 5 over n plus 1. Well, what is that going to be? Yeah, the n plus 1 is going to approach infinity, so we get 5 over infinity, which is 0. So this limit here is going to be 0. What does that tell me, using the ratio test, about this series right here? It converges. So since this, in fact, I need to write this here. Since 0 is less than 1, so the limit of the n plus first term to the nth term is less than 1, then we can say that the series converges. And why does the series converge? What did we use? I want you to get in the habit of being sure that you, first of all, write down the hypothesis part of the theorem. In this case, that limit of the terms has to approach a number less than 1, so we're going to show that's less than 1. And then tell what test or theorem that we use to show that it either converges or diverges.